Alright, today is 12.2 on conditional probability. You can see that up at the top there. Again, similar to yesterday's notes, you're going to be writing this stuff down on notes in class. So if you are not in class, you might want to just watch it from here, write your own notes, and I will tell you what to do. First of all, you're going to do is define conditional probabilities. What I would want you to do is to read through this paragraph and then try and put it in your own words. Okay? Then I would have you compare it with a neighbor, and then we would discuss it as a class. Here's what it says. Conditional probability contains the condition that may limit the sample space for you. You can write conditional probability using this notation, and here's the biggest key here. The probability of event B given A. That's how you say that right there. The probability of event B given A. So this little line means given. Okay? What does that mean? The probability of something happening given something else happening. The probability of me sleeping is contingent on whether my kids sleep. The probability of me eating given that I'm hungry versus when I eat versus given that I'm not hungry is going to be a much higher level. Okay? Let's look at some examples here. Example 1 says the table shows the results of a class survey. Find the probability that somebody did a chore given that they're male. So we want to look in the male column, and the answer here is 7, okay, out of a total of, well, you don't add them all up because I'm given the fact that it's male. There's 15 total males. So the fact that it's male limits it to 15 possible outcomes. Of the males, 7 did a chore, so the probability right here is just 7 out of 15. I'd like you to try one to find the probability of a female that did a chore. So again, that it's a female and given that they did a chore. Try it once on your own, press pause, come back and check. So here's the thing, it's given that they did a chore. So that's my denominator basically. That's why we had 15 here, because there were 15 males. So yes, they did a chore, gives me 14 possibilities, to use a funny word. And given that they're female and that they did it, was another 7 out of 14, which of course is 1/2 as a fraction. Okay? 1 out of every 2 did a chore. Alright, let's move on to example 2. You can see here that it says Americans recycle increasingly more materials through municipal waste collection each year. The table shows recycling data for a recent year, Find the probability that a sample of recycled waste was paper. Well, here's paper right here, right? Okay, and it's I'm going to go to the bottom of the next page because it does show kind of how we're doing this, okay? Given the conditions, we have to limit the sample space to just recycled waste. So we're only looking here in this column here. A favorable outcome is recycled paper, so that's where they get the 36.7 on top, okay? Then we have to take the total amount from just the recycled column from here. That's how I get in 6.3, 2.4, 1.4, 21.2, all these numbers. They added those all up, took 36.7 divided by that, and they got a total of 0.54, which again is 54%. I'd like you to do quick check too. I'll leave this table up here. Find the probability that a sample of recycled waste was plastic. Try that. So the plastic is 1.4 divided by the total of recycled, so I'd have to add all these up. By adding those all up, by the way, you get a total of 68, and when I divide it, I get 0.0205, which is 2.1%. That is the answer. Okay? Alright, let's go on to the next example. Well, first thing I want you to do is I really want you to copy this right into your notes. Conditional probability. Go ahead and press pause. Copy that in. Its probability of B given A for any 2 events can be found by the probability of A and B divided by the simple probability of just A. Doesn't make a lot of sense until you actually look at some examples, but once we do, that'll be an easy formula to get. So in other words, let's look at example 3 here. Okay? If I do some researchers, they're asking shampoo users whether they apply the shampoo directly to the head or indirectly using a hand. Okay, so think about, what do? You know, it might seem a little weird. Some people put it right on their head. I'm one of these put it into my hand first people. I don't know about you. So what they want to do, again, find the probability that respondent applies shampooed directly to the head, given that they're female. So we got to add up the female column here. We get 30. I'm just going to do them all here. This is 20. If I go down, this is 8. If I go down, this is 42, which makes sense. 50 and 50 should be the way both directions. So here's what it said. The probability that they're female, well, there's 30 out of the 50 were female, right? But the probability that they're female and applied it directly to their head was just this 6 out of the total 50 people that got taken care of. Okay? So, probability that they're female, given, probability that they apply it directly to the head, given that they're female, is, well, look at what they're doing here. They're taking the probability of A and B, which is 6 out of 50, and dividing it by 30 out of 50. So once we found those two amounts, well, that's just a keep it, change it, flip it type of problem. The 50s will cancel. 6 over 30 reduces to 1/5. That's how they're getting that answer right there. Okay. So the quick check here is 80% of an airline's flight depart on schedule. 72% depart and arrive on schedule as well. Find the probability that a flight departs on time and also arrives, that a flight departs on time also arrives on time. So I'd like you to try and think about that a second. Again, what you're finding is the probability both depart and arrive on schedule divided by probability of just depart on schedule. That should make it really easy, but go ahead and try it out. Come back, check your answer. 0.72 divided by 0.80 is going to be a 0.90, which is 90%. Okay. So, given that it departs on schedule, generally it arrives on schedule as well. Makes sense, right? Let's go to the next page then. Do an example 4 here at the top. We're going to make these tree diagrams. Okay. Tree diagrams are a little bit difficult to figure out, but they're not that bad. We can set it up and try and figure out like what goes where. So here it's saying 5% are heavy of snows. School is closed. So if 5% are heavy, then 95% are light. That's how they kind of come up with the first two columns. Okay. After a heavy snowfall, so we're looking at this branch here, 67% are closed, which means 33% of the time they're open after a heavy snowfall. After a light snowfall, so this way, less than 6 inches snowfall, it's closed 3% of the time, it's open 97% of the time, because again, that's the other part of it, right? Find the probability that it's light and the schools are open. So we're going this way and we're going this way. Okay, so we're gonna keep going here. The answer is not just 97%, it's kind of a double percent, right? So you can see again, what they're gonna do here is they highlighted kind of where it is, and we've got the path is P of L. Look right here, let's circle this. So all they did was multiply 0.95 times 0.97 because that's those two probabilities. Multiply together, they get this, which gives me, well, 92.2%. Okay. Find the probability that schools are open given it's heavy snow. Use the tree diagram, find the probability, go. So again, the probability that it's heavy, given that schools are open, so it's heavy is 0.05. Schools are open, that's 0.33. When I multiply those together, I get 0.0165, which is about 1.65% of the time, or 1.7, I guess, if you want to go there. So your homework is 1 through 12. You can see 1 through 8 here, but if you look at Google Classroom, you'll see the other four as well. Again, the homework is page 656 through 657, number 1 through 12. Okay. Have a good day.